Hi and welcome to video 3 of this PSMT guideline video series. So we're going to talk about how this is marked and introduce you to the ISMG, which is the criteria sheet or the marking guide for this process. So let's have a look. So a PSMT accounts for 20% of your overall grade. And I won't introduce this for every video, but I'll just talk about it briefly now for the first criteria. The criteria are broken down over 20 marks. So this is out of 20 every time we do it. So just expect that, PSMT 20 marks, and you're aiming for that 15 plus. So let's have a look at the first one. Formulate is the first one, as according to the modelling and problem solving flowchart. So in Formulate you can get up to 4 marks. Now I'm going to be honest with you, the first 2 marks are pretty trivial. You just make some comments about stuff, talk about how you're going to solve it really briefly. Doesn't even have to be that accurate, and you're going to get the first 2 marks. It's pretty hard to not get 2 marks out of 4 here. But 2 marks out of 4 is not really good enough, because a PSMT is where you want to front load some good grades to take the pressure off the exam. So we're looking here for 3 or better yet 4. And 4 is not that hard if you take on the advice that I'm going to give you now. So we've got 3 criteria there: documentation of appropriate assumptions, accurate documentation of relevant observations, and accurate translation of all aspects of the problem by identifying mathematical concepts and techniques. The first 2 are the 2 we find people have the most trouble with. So I'm going to go through them in a little bit of detail and define some terms. Then I'll talk briefly about the third one, and then we'll talk overall about a couple of expectations and things that we as a group of teachers have learned. So assumptions and observations first of all. You can see my purple and red there, and my way that I've interpreted the definitions. So an observation is something you notice is important for solving the problem. So when you open up the task and you look and you see the problem and you think, I really need to know this. That's an observation. Or, I think that's going to have an effect here. That's an observation. So when you first read the problem, the first thing you should be doing is noting down all the things that come to mind, because they're your observations. An assumption is a decision you have to make due to a lack of information. So, this is going to affect it, is an observation. How am I going to fix that? I'll assume that it has this effect, or it's negligible, or it doesn't exist. So there's an assumption. So I'll go through a couple of specific examples for this later on, but that's the general principle. You'll often find that they're made early in the task, but also throughout the task. We see people generally summarising them all at the start, even if they're sort of adding them in later on. But you can technically have an observation or assumption anywhere throughout your task. Just again, if you're not going to put them in the initial stages of the task, if you're going to raise them later on because that's more relevant to you, perfectly fine. Just make sure that's really clear to the marker that that's what you've done, using the word assumption and observation, and it will definitely get you some credit there. Observations and assumptions are typically tied together as well. Not always, but you'll often make an observation and therefore make a relevant assumption associated with that. You'll see here on the page I've got, for example, I've observed that there is wind in my throwing location. So if you've got a projectile motion math methods task, and therefore I'll assume the wind does not affect the motion of my throw. So there's just a really simple example. So let's talk about documenting, because if you remember, if I go back quickly to here, to get the 1-2 band, you need to just state some assumptions and observations. To get the 3-4 band, you need to document. You'll see that, documenting. So we're going to talk quickly about documenting. So the QCAA cognitive verb document means to support with evidence. You'll see the full definition there, but those 3 words are the key. Support with evidence. So if you make a statement, so you say, let's go back to my original example, I assume the wind does not affect the motion of my throw. Well, that is a statement. I haven't actually given any support to that, provided evidence, provided any reasoning. I'll talk to you more about how to do that in a minute, but this is currently a statement. So I'm supporting with evidence. We also think, and this is where my examples are going to come from, we think that there are 4 main ways that we commonly see people deal with assumptions and observations, and in terms of documenting them. So you might provide a relevant reference to provide evidence for the assumption. So that's the first way, and also the most common way, but we really want to make sure that you understand it's not the only way. We may explain a specific effect of making the assumption, or maybe the effects of not making the assumption. So you might talk about how the assumption affects it. You may elaborate on the necessity of the assumption by considering decisive information. So you notice in this definition, I'm just going to shoot back a little bit, there is e.g. decisive information. So decisive information is information that definitively tells you something, decisive information. Could you solve the problem without the assumption? So you could talk about that. Or you may provide evidence for the assumption presented in a specific research fashion. So you may actually show, well, this assumption I need to make and actually exists because of X, Y, Z. So I'm going to show you some examples of these now, and it's a similar process for observations. So the first one is providing a relevant reference to provide evidence of the assumption. It is assumed that 3-bedroom houses are the best choice for my data collection. So this is a data collection task in Math General. As according to the website domain.com.au, more people live in 3-bedroom houses than any other configuration. Reference domain 2020. So this is a documented assumption because I've provided a reference and evidence to support making that assumption. There is a little bit of a note here. If you write one sentence, it's almost certainly only stated. So there's a little bit of a trigger for you. Second one, and this is the green one, explaining the specific effects of making the assumption, or maybe the effects of not making the assumption. It is assumed that the wind resistance for the throw of a tennis ball is negligible. So I'm assuming that wind doesn't affect the motion of the tennis ball. And then in green, whilst it is clear that there will be drag and resistance, the effect it has on a ball is to hinder the motion, but only slightly. This can be seen by considering the effect of wind resistance opposing the motion of an object and the minimum opposing force it would apply. So this doesn't have a reference, but it does explain the fact that I understand, as the person writing the task, that there is some wind and drag, but it's fairly negligible on this type of ball. If it was a tennis ball or a golf ball, well, I wouldn't make this assumption if I was throwing a balloon, of course, because that has a larger effect on a balloon. Purple, the third method. Elaborating on the necessity of the assumption by considering decisive information. Could you solve the problem without the assumption? I will assume that the starting temperature in each coffee cup is the same. So this is a measuring temperature decline in coffee. It's important in this task to be able to effectively compare each model, and this can only happen if the initial values are equivalent. So this is pointing out the fact that to build the model and to make a fair comparison, we need to start with the same temperature. In this instance, some of the data I've collected is secondary data from a video provided to the class. So this provides that decisive information that there is some video data provided and some information about what I can do with that data and how I can match it up so it starts at the same time frame. And then, of course, that means that I've got fairness and I can make the comparison. And the fourth one, evidence for the assumption presented in a specific research fashion. In the process of comparing a sports team to ascertain who is the best, it's become evident through the research that being the best in tennis is based on some significant criteria. These include winning the most Grand Slams, as most fans rate Grand Slams far higher than normal tournaments, as almost all of the best players are present. Longevity of career is also important, as there are numerous players who have had good years, but very few who are able to maintain this over a significant period of time. Finally, style and finesse. It's apparent in reading popular media articles about tennis, that players who can excite fans through their play also receive the accolades are considered significant members of the sport. So this is evidence for the assumption presented in a specific research fashion. I've not referenced, so it's not the first one, but I have provided information about my research here and provided that list for why it's an important assumption to make. So there's some information about how to come up with assumption observation and some ways that you might present documenting your goals. You'll note also the words appropriate and relevant. So I need to document appropriate assumptions and relevant observations. So there's a couple of things we've learned here. First of all, appropriate assumptions will mean you're not really mucking around with assumptions like, I assume my calculations are correct. That's not really appropriate. As you're doing the task, we would like to think that your calculations are correct, and we will be checking that. Secondly, that relevant, so relevant observations, you've got to make sure that the observations you make actually tie into the task, actually are considerations that are important. So there's some relevance there. Lastly, though, there's a couple of things that we've learnt in our time in teaching and also being part of QCAA roles. And the first one is that at this level of documenting, we used to say something along the lines of, you need to provide 5 assumptions and at least 3 of them must be documented, or at least 2 of them must be documented. We can't really provide you a numerical value. We tend to find, depending on the context and the task, different tasks require different numbers of assumptions and observations. So we're never going to provide you with that exact number that you need to reach. What we are looking for is reasonable coverage of the main ideas. So just keep an eye on that and keep that thought process going. You may get up to, and we've seen, maybe 8, 9 or 10. But typically, once we get past 5 or 6, we tend to find they repeat a bit. People are writing the same assumption. So they might say, I assume that wind doesn't affect the motion of the tennis ball throw. And then they might say, I assume that drag doesn't affect the motion of the tennis ball throw. Well, it's kind of the same assumption. So there's some little things to think about there. The other thing we found out quite recently is that for us to provide the documenting mark, there's an expectation that you will have documented at least half of your assumptions or observations. Now, this can be tricky because you have a word count and a page count issues. So you have to be careful here, because if you start throwing out 10 observations and assumptions, you kind of need to document 6 of them. But that's going to be a bit of a problem for your page and word count. So I would try and bring those assumptions and observations into groupings a little bit better. Aim to have 5, give or take, and then document maybe 3 of them. So there's some ideas for you to think about. Take some time to proofread and consider the assumptions and observations you've made. Are they appropriate? Are they relevant? And are they necessary? The third dot point of the Formulate criteria is accurate translation of all aspects of the problem by identifying mathematical concepts and techniques. So in this third dot point, it's pretty simple to cover. You just need to make sure you do. Before you get onto the solve section, you need to have identified how you plan to actually solve the task. And this should be part of your Formulate. So how are you going to do it? And that will be part of identifying the mathematical concepts and techniques. I will show that player Z is the best tennis player because of, they have been the best over a longest period of time and they've won the most Grand Slams. And I will use box plots, stem and leaf graphs, and histograms to compare them with other players. So we've got that. I'm going to use these mathematical techniques. And I will be calculating the average time it took between Grand Slams or something like that. So this identification of how you plan to solve the problem, have that before you actually solve it. Okay, so that's the end of the Formulate section. I hope that the rain that just began to fall didn't really get too much in the way of the microphone. But otherwise, thanks for watching.